Okay, boys and girls, welcome back from winter break. We are going to move into a unit talking about even and odd numbers, and next week we're going to get into prime and composite. So, for this first week, we're kind of just easing into school again and kind of going light on the topic. So, even and odd numbers. And you might be thinking, haven't we already learned this? And yes, you have learned what even and odd numbers are. You start that in first grade, I do believe. So, what are even and odd numbers? An even number is a number that has the digits 2, 4, 6, 8, or 0 in the ones place. When you first started learning about even and odd numbers, you might remember focusing on cubes. And if your cubes had a buddy, such as these two, these two are buddies, and these two are buddies. So if everybody has a buddy, then you know that your number is even. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 blocks. Every block has a buddy, so we know that our number is even. And as you get into larger numbers, such as these, you're not going to have 164 cubes to throw out on your desk. Or 23,000 cubes to throw out on your desk. So there's an easier way to determine if a number is even, and all you have to do is look in the ones place. And so if you look at the number 164, I know that this number is even because the 4 in the ones place is an even number. So your digits, you only have 10 digits in the number system: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So if your digits are 2, 4, 6, 8, or 0, and those digits are in the ones place, then you know right now that your number is even. If you look at 38, I have a 3 in the tens place. 3 is odd, and 8 is even. 8 is in the ones place, so 38 is even. In the number 23,476, I don't have to look at any of the other digits except for that 1 in the ones place. So this 6 makes that number even. And then in our last example, 15,732, all of my digits are odd: 1, 5, 7, 3, except for that digit in the ones place. And that's the one that determines if your number is even or odd. Okay, so here are your even number examples. If we go to the next slide, same thing with odd numbers. Odd numbers have the digits 1, 3, 5, 7, or 9 in the ones place. So if you go back to thinking about when you were in first or second grade, and you worked with blocks or cubes a lot of the times, if I have 1, 2, 3, 4, 5 of these teal cubes right here, and I partner them up so everybody has a buddy, this guy on the end doesn't have a buddy. So he's a little sad. So this represents an odd number. Okay. And again, here are some examples, and all you need to do is look in the ones place. So the number 47, I have a 7 in the ones place. So that would make that number odd. 865, I have a 5 in the ones place. So that number would be odd. 22,849. My 9 is in the ones place, so that number would be odd. And then 263, my 3 is in the ones place, and therefore that number is odd. Okay, so that's the basics, even and odd numbers, how to determine quickly whether or not you are working with even and odd numbers. We do have some rules to talk about. Let me get my screen up here. We do have some rules to talk about with even and odd numbers. And starting with some addition rules, okay? And I'm going to reveal all of these at once. When you add an even number with another even number, your result or your sum is always going to be even. Okay, this is going to be important for you to remember. So an even number plus an even number will always result in an even number. If you're having trouble remembering these rules, just try a simple example problem out. For example, 2 is an even number. If I add that to another simple even number, say 4, then my result is going to be 6. And that works every single time. When you add an even number with an even number, your result or your sum will always be even. Okay? When you add an even number with an odd number, your result is going to be odd. For example, if you did a quick example problem, let's say I had 4 as my even number, and to that I'm going to add 3, which is odd. My result is going to be 7. Okay, you can do a very quick model of this. If I did, let's see, let me do this. If I had 1, 2, 3, 4 plus 1, 2, 3, and then I did my partnering up method like that, 4 plus 3 is going to result in an odd number. This guy over here is going to be left out. Let me do an example down here. Odd plus odd will always result in an even sum. So if I had 5, which is odd, plus 3, which is odd, my sum is going to be 8, which is even. So why does that happen? All right, so if I did my little model here, just ignore this right now over here. If I had 5, 1, 2, 3, 4, 5, plus 3, 1, 2, 3, and I did my buddy model here. These guys are buddies, these guys are buddies, these guys are buddies. The odd from the one left out from the 5 and the one left out from the 3 became buddies, which resulted in your even sum. Okay, so you're left over from the 5 and you're left over from the 3 partnered up. So odd plus odd will result in an even. So if you get tangled up with remembering which is which, just do a simple example problem like one of these over here. Okay? And the rules apply also for subtraction. So it's the same thing. So an even minus an even will result in an even. If you need to come up with a little sample problem, you could do that. So if I said 8 minus 2, even minus even equals 6, which is even. Even minus odd, let's say 6 minus 3. There's my even number minus my odd number. 6 minus 3 is 3. That results in an odd number. And then an odd minus an odd will result in an even number. So try it out. So 7 minus 3 equals 4. So if you have trouble remembering these steps, or these rules, I should say, just come up with a little example problem. All you need is one, because it applies to every single time you come up with an example problem. So just make an example problem and test that out. Okay. But if you notice that your 3 sum rules are the same as your 3 subtraction rules. So if you're adding 2 evens or you're subtracting 2 evens, your result is evens. If you have one of each, then your result is going to be odd. If you have odd, odd, and then odd, odd, your result is going to be even. Okay. Something that we're going to be getting into next week is prime and composite. So let me talk a little bit about some other rules for even numbers. Okay. All even numbers are divisible by 2 or have 2 as a factor. So divisible by 2 means that you can divide an even number equally into 2 groups. Okay. In other words, you can split it right down the middle and you'll have the same amount in both groups. And if it's divisible by 2, then 2 is a factor. Okay. Remember, your factors are your numbers that you multiply to get another number. So if I had 6 cubes here and I divided those 6 cubes by 2, that means I would have 2 equal groups of 3. And you can do that with every even number. Okay. So if your number was 23,624, because this is even, then you know that this number can be divided into 2 equal groups. Okay. Odd numbers are not divisible by 2. So if I had 1, 2, 3, 4, 5, 6, 7 cubes, 7 is odd, I am not going to be able to divide this group of cubes into 2 equal groups. I will always have 1 extra or 1 left over. So odd numbers are not divisible by 2. So if I had a big, large number like 35,783, I know that because this number is odd, I am not going to be able to divide it into 2 equal groups. And that is going to be important when we start talking about prime and composite numbers next week. So if you are feeling froggy this week, you can start looking up some things about prime and composite numbers. It's one of my favorite things to teach, and I am excited to get into that next week. All right, if you have any questions, you can email me, and good luck with the rest of your work this week.